All right, so what I would expect or what I would encourage you to show, because the AP exam is a little iffy sometimes on what they expect you to show, or what's required to show, is I would at least put in that part. This one is not terribly difficult because you don't have to change anything with y, so you just plug it in as it is. 0.8 times the log of 2 plus 1.2, so you get 1.4408. This obviously has no particular context, but a couple things you need to make sure of. Make absolutely certain, because I know this will ding you on the exam, that you have that predicted symbol over your y variable, and that you have it in context. So, as I mentioned, this obviously doesn't have any context, but whatever your problem has to do with, make sure you put the label on it. Or that your y is not just y, it's your actual variable in context. Yeah.
How many decimal points do they expect it?
I've never seen any particular requirement on the number of decimal points. They often will go about 4. So that's usually what I tell people, 3 to 4. All right, so on the next one, we have log of our predicted y equals 1.2 plus 0.8 times 2. So 1.2 plus 0.8 times 2. I don't actually think I need those parentheses, but I'm going to put them anyway. So our log of predicted y is 2.8. And then on the calculator, second log, so that 10, or you can just do 10 to the power of 2.8, or you can put in second, the negative sign to put the answer up. And that is 630.9573. So our predicted y so some of you have a tendency to write little or no work on your stuff. I would discourage that, just for your own sake. All right, any questions on the first two? All right, so ln of our predicted y, 1.2 plus 0.8 times the natural log of 2. Make sure you pay attention to stuff like this. For some reason, when it's in there with x, a lot of people tend to miss it. So make sure you're paying close attention to re-express data. So 1.2 plus 0.8 times the natural log of 2. So 1.7545. And then second natural log, so that gives you, so that's this button right here, that gives you e to the power of, and then if you just want to pull up your answer, you can do second and then the negative sign, and that will give you, that will put your answer from the previous one in there. So 5.7807. So the predicted y, 5.7807. Any questions on that one? Okay. So our predicted y squared, 1.2 plus 0.8 times 2. I think we already did that. So 2.8 equals the square predicted y, and then to undo that, we square root both sides. So 1.6733 is our predicted y. Any questions on that one? All right. So 1 over the square root of your predicted y equals 1.2 plus 0.8 times 2. We already know that is 2.8. And On the AT exam, they give you lots and lots of space to do these problems. So use your space, but remember you don't have to use your space. They always give you more space than you need. Alright, so, long way of going about this. Let's see, which way do I want to go about this? How did you guys solve this? Seeing where your brains went on this one. So 1 over 2.8. Okay, so I'm going to not skip those steps just because some people are not comfortable with that. Okay, so I'm going to show you kind of the long way about this. There are definitely shortcuts. If you use them, that's just fine. So I'm going to multiply both sides by the square root of predicted y, just to show you how we get there in the long run. Then divide both sides by 2.8. So we have 1 over 2.8 equals the square root of your predicted y. And then to undo that square root, and square both sides. So we end up with squared 1 over 7.84. And this is probably going a bit far in terms of how much work you're showing, but so 0.1276 is your predicted y. Any questions on that one? Oops, sorry. And as I mentioned, that's probably going a little bit extreme in the work shown, but I've found in the past when I don't show the steps, some people get lost on how to solve that algebraically. Any questions on any of these? Okay. So, as I previously mentioned, that's probably the main way you're going to need anything from Chapter 10, other than knowing what free expressions to do when, or at least that the log one undoes the curved, the kind of exponential curved ones.